today we're going to talk about discontinuity. I like discontinuity a lot. All right. You do have a new poster on the wall. So everybody look over there. I've got the 3 different types of discontinuity on the wall. Those are the only different types of discontinuity. So we have jumps, holes, and vertical asymptotes. We've already talked about vertical asymptotes in this class, so we're going to talk about those again. Hopefully that's a refresher. Jumps and holes are I think, going to be new, but you should have talked about holes last year. All right. So let's look at this first, this chart here. And we're going to first talk about holes. Holes are the hardest one because holes can come from rationals, which is the fraction, or from piecewise. All right, so you could get a hole in either situation. Holes are also called removable discontinuity. So it might tell you on the test, find all the removable discontinuities, and they would be talking about the holes. It is a vocab word that you need to know. All right, so removable means hole. Think about if you picked up and removed a point, it would give you a hole on the graph. Vertical asymptotes and jumps are both non-removable. All right, so vertical asymptotes and jumps, non-removable. All right, on this graph, I'm going to show you what a graph of a hole looks like. It's going to be something like this, where there's literally a hole in the middle of your graph. Even if you have this random point placed somewhere else, it is still a hole. So there is an open circle here. Your lines are meeting up, but there is a break in the graph in this open circle. That would be a hole. So what you need to look for from a piecewise is this symbol right here, the cannot equal to. All right, because this is telling me that my point is at 0, 3. So a point is getting moved to 0, 3, but the rest of the graph is going to be y equals x. So that's kind of what I graphed here. So this whole graph is y equals x, this linear line, but at 0, we're going to have the point is getting moved to 3. So it's like we're removing this point here at 0 and we're putting it at 3. So that's why it's called a hole or removable discontinuity. Does that make sense? Okay. So how to find on your piecewise graphs. You are either going to look for this symbol, the cannot equal to symbol, or if your inequalities do not have lines underneath it, you also would have a hole there. What's up? And I have an example with the inequalities here later on. But the more common hole is going to be the cannot equal to, the equal sign with the cannot equal to. All right. Now, hopefully this next one here is a little refresher from last year when you talked about rationals. My first step is going to be to factor. So on the top, what multiplies to give you 1 but adds to give you 2?
X plus 1, X plus 1.
Yes. All right, so first step, factor. Second step, cancel. What cancels?
X plus 1, X plus 1.
The x plus 1s. That's where your hole is going to be at. So if you have something that cancels on top and bottom, that is your hole. Now we got to figure out where it is. Where is my hole going to be located at? So we got to find x. So we're going to take what I canceled, equal it to 0. So what is the x value of my hole? -1. All right, but we got to plug it back in to find y. All right, so we're going to plug it into the remaining function. To find y. So we're going to take -1. This guy here is what's remaining. So the x plus 1 is what's left over. After I canceled these factors, I'm left with an x plus 1 on top. Does that make sense? So to figure out this y value, I'm going to take -1 and I'm going to plug it back into what's remaining. And that's where my hole will be at. So -1 plus 1 is going to give you 0. So the y value would be 0. So on my graph, I would have a hole at -1, 0, and the rest of my graph is going to look like that leftover function, the x plus 1. I forgot to write the hole is at 0, 0 on this first one. So fill that in. That's my bad. All right, so that's holes.
Yay.
Are we good?
Hooray. Can we watch the movie now?
The movie holes.
That's a lot of
I'm tired of this, Grandpa. Yes, it's from the movie. What do you mean that's not from the
I didn't
movie?
say that. I said I don't remember that part.
That is from the movie. That's the background of the
Okay, we established.
Yeah, where she's a little girl and she's digging holes and she goes, "I'm tired of this, Grandpa," and he goes,
That's too damn bad.
"Yeah, that's
That's too damn bad.
Exactly, just like that. I'm so glad that was on the recording. All right.
You started the biggest laugh of all.
Alrighty. So the next thing is the vertical asymptotes. How do we find vertical asymptotes?
Set the bottom.
Set the bottom equal to 0. All right, so anything left over on the bottom gets set equal to 0. That is going to give you a VA. So on this one, x plus 2 and x minus 2, they do not cancel. So we are going to take whatever's on the bottom, and we're going to equal it to 0, which is going to give you 2. So we would say that we have a vertical asymptote at x equals 2. And graphically, it looks something kind of like that. And you would have a vertical asymptote. Now, vertical asymptotes, you don't need to find a y value. It is just x equals. That is where your vertical asymptote is. The only thing that needs a specific coordinate point is a hole. All right, so VAs and jumps, those are just going to be x equals. All right, so bottom equal to 0. We've already done that a couple times because we did that when we found our domain rules, because that gave us a domain restriction. And then we did it again when we were looking for our asymptotes, right? Because we did vertical asymptotes and horizontal asymptotes and slant asymptotes. So we talked about vertical asymptotes then. And now we're going to talk about it again because it is also a discontinuity point. All right, so we talked about vertical asymptotes a lot so far. All right, and then the very last thing is going to be a jump. Now, the jump only can happen on a piecewise. All right, that's the only time a jump can happen. All right, so only a piecewise. And so what we're going to do to figure out the jump is we're going to figure out our endpoints. So when I plug 0 into x squared, what am I going to get? 0. And when I plug 0 into x plus 1, what am I going to get? 1. Are those points going to match up? No, one of these guys is going to end at 0, 0. The other one's going to end at 0, 1. And so we are going to have a jump because they are not going to match. What x value will I jump at? 0. The x value that I'm plugging in, that's where you're going to jump at if it doesn't match. All right, so we kind of graphed these already yesterday, but this endpoint here is going to be at 0, 0, and that graph looks like a quadratic. And then we have another one here at 0, 1. That one looks like a linear. So you can tell right there at 0, your function breaks apart and it would jump. All right, so only can happen with piecewise, and it is when endpoints don't match. All right, so when your endpoints don't match. And those are the 3 types of discontinuity, the only types of discontinuity. All right, so if you're needing to check for discontinuity, that's what we're checking for, jumps, holes, and vertical asymptotes. All righty? All right, so let's do these couple examples here. We'll start with 31. Yes, this is it. Okay, so I heard at x equals 2, there's a jump. What other discontinuity are you seeing?
Vertical asymptote at 4.
Good. VA at x equals 4. Okay, I've got one more. A hole. Very good. So the hole we're going to describe as a coordinate point, -3, -2. All right, let's go over here to 32. Good. Jump at x equals 4. Good. And then we got a hole right here. So for the hole, we don't care about this random point that got moved. What I care about is where the hole is on the graph. Because these lines match up, it is not a jump. It is a hole. 6, 6. And then we got a VA at 0.
But what about the hole at 2, 1?
Yes, we also have a hole there. VA at x equals 0. And then the very, very last one, hole at 2, yeah, 0.5, 0.75. I believe that's one. All right, and then that covers all the discontinuities. All right. So do y'all think, are we good from a graph being able to identify them? Okay. So now let's talk about equations. All right. If you have a fraction, the first thing you're going to do is factor, because we need to figure out if stuff cancels. So what multiplies to give me -18 but adds to give me 3?
6 and 3.
Yes. So +6 -3. All right, so then after you factor, you're going to look and you're like, okay, does anything cancel?
Yeah, there's a hole there.
So something cancels, we do have a hole. To figure out the x value, whatever you canceled, so in this case here I canceled x -3, set that equal to 0. So what would the x value of the hole be? 3. And then after you cancel that x -3, all I'm left with is x + 6. And to figure out the y value, we are going to take 3, plug it back into what's left. So 3 + 6, which is 9. So I would have a hole at 3, 9. Do you have any other discontinuities?
Can't you still find the VA? Or not possible?
No, it's not. So after you cancel it, it's just a hole. It's not a VA.
So then
Yep. So nothing is left on the bottom. So there are no VAs.
So there's only a VA if something is left on the bottom.
Yes. Okay, let's hop over here to 34. So 34 is a piecewise. For piecewise, we check for jumps. So I'm going to plug 1 in. When I plug 1 in, what do I get?
-2.
Are you sure?
Yes.
+1?
Well, I thought you just meant right there.
Gotcha.
+1 is there.
Yep. Okay, when I plug 1 into here, -4 times 1 is?
-4.
+3?
Negative.
-1.
And there is
Right. So, are these guys matching up? Yes. So, is it going to jump? No, because they're going to match up. Is my point going to be closed? Yes, because it has this or equal to guy right here. So, it's going to be closed. It's not jumping. So, this one here has no discontinuities. Discontinuities, maybe? All right, so remember the only types of discontinuities are jumps, holes, and VA. So if you don't have one of those guys, we're good to go. All right, let's go to 35. All right, 35 is a fraction. We are going to factor first. So the top is x plus 1. X plus 1, x minus 1. All right, so does anything cancel?
Yes.
Yes, which is going to be a whole. Now, sometimes it might be helpful, after you cancel, write what you have left over. What is left over? Is it on top? Yes, it's on bottom. And then there's an understood 1 on top. All right, for the x value of the whole, whatever you canceled, x plus 1, we're going to set that equal to 0. So what would the x value be? -1. And then we're going to take that x value, we're going to plug it back into what's left. -2. Where's it, though? It's in the bottom. And we still have that understood 1 on top. So the y value would be a -1/2. All right, so yay, I found my hole. Now, do you have anything else?
Yeah, you have a VA.
We have a VA, because there is something left on the bottom of my denominator. So I have a VA. Where's your VA going to be at? X equals 1. So kind of the same thing. Whatever's in the denominator, set it equal to 0, and that will give you your vertical asymptote. So if you have anything left over in the denominator, that would give you a VA. All right, let's go to the right. Let's do 36. All right, 36 is a piecewise. So we're going to check our endpoint. So I'm going to plug 3 in. 2 times 3 is? Plus 1?
7.
That's not planned. It was just already like that. What's 3 squared? 9. All right. So on this one, are my endpoints going to match up?
Your X will.
The x's always will be the same. That's what we're really kind of checking the y's. So the y values, they're not going to be in the same spot, right? One's up here at 7, one's up here at 9. So because of that, we are going to jump at x equals 3. Yeah, so someone had a good question for me. They're like, are these x values always going to be the same? Yes. So these guys here should be the same number that you're plugging in when you're checking for jumps. Okay, let's go to 37. So 37 is a fraction, so we have to try to factor. What can you take out of the bottom?
X.
An x. And I'm left with 2x plus 1. All right, does anything cancel?
No.
No. So do you have any holes? No. All right, do we have stuff left on the bottom?
Yes.
Yes. How many factors do we have on the bottom? We have 2. We have the x and we have the 2x plus 1. So how many VAs are you going to have?
2.
We're going to have 2. So when you take the x and you equal it to 0, you're solved. All right, there's nothing else you can do. One of your vertical asymptotes is going to be at x equals 0. And then we're going to take the other one, 2x plus 1, and equal it to 0. Yep, subtract 1. Divide by 2. And you get -1/2. So we would have 2 VAs at 0 and -1/2. All right, almost done. Go to 38. All right, on 38, when I plug in 0, what's 0 squared?
0.
Times 3
0.
plus 1?
1.
Perfect. And when I plug in 0 into the 4,
4.
4. So are they matching up?
No.
No, so what do I have?
Jump at 1 or
X
X equals
equals,
0.
yes. All All right, almost done. 2 more. All right, on 39. Do you have a fraction?
No.
A fraction with x in the bottom? No. So no fraction with x in the bottom. It's not a rational. And is it a piecewise? No, it's just a polynomial. So since it's not a piecewise, you're not getting any jumps. And since it's not a rational or a fraction with x on the bottom, you're not getting any holes or vertical asymptotes. So since you don't have any jumps, holes, or vertical asymptotes, do you have any discontinuities? No, so no discontinuities. You can also put continuous instead of writing no discontinuities. If you see the word continuous, that's the same thing. All right, now the last one. This one here is the challenge question. All right, since it's a piecewise, the first thing I'm going to do is check my endpoints. So when I plug 0 in, what do I get? 1. When I plug 0 into the second one, what do you get?
2.
And when I plug 0 into the last one, what do you get?
1 over 1.
1. All right, so do my endpoints match up? Some of them do, right? 2 of them do. This one and this one match up, but that middle guy doesn't. So look at your domain restrictions. All right, this is, like I said, it's the challenge one. All right, so the right function, because of the greater than sign, the right function is going to 0, 1, and the left function is going to 0, 1. Yeah. But the random point, the x equals 0, which is just a random point, is just somewhere else.
Yeah.
All right, so what's happening on this graph is the one function is going over here to 0, 1. The left function is going over here to 0, 1. But there's a random point at 0, 2. Does that make sense? So what kind of discontinuity would that be? A hole. All right. So the 2 sides match up, right? 0, 1 and 0, 1. Those match up, but the point is not at that spot. So that's why there's a hole there. So we're going to say that there's a hole at 0, 1. And there's something else. Close. It's not a VA though, but I do see a fraction. So I'm like, okay, well that might also have discontinuities. What's the first thing you have to try to do for the fractions?
Solve that.
Factor. So what does the top factor out to be?
1, 1.
X plus 1, x plus 1. So then what are you seeing? It cancels. So it's not a VA, it's a hole. What's the x value of this hole? -1. And then when you plug it back into the remaining, you get 0.
There's 2 holes.
So there's 2 holes. So that one's tricky because it had a fraction in the piecewise. So you kind of had both. Okay. Questions on today's lesson at all? All right, remember, make sure you're getting your homework taken care of. Tomorrow, you have a little bit of an extra credit opportunity. So tomorrow's review day, but we're also going to do, I have these task cards over discontinuity that we're going to do. It's going to give you an opportunity to earn some points if you need to earn some bonus points for tests or quizzes or whatnot. So that'll be tomorrow. You also will have a review, but I'll post a video and stuff like that. Make sure your homework is getting completed. All right, if you're saving all of this until Wednesday night, you are going to be hurting. So make sure you get it done.
This is tomorrow the last day for test corrections?
Yes, tomorrow's the last day for test corrections.